In this video, I'll show you how to solve the ALEKS problem called using the Arrhenius equation to calculate E sub A from K versus T data. To solve this problem, we are going to be using the Arrhenius equation in this form, the natural log of the rate constant number 1 over the rate constant number 2 is equal to E sub A, which is what we're trying to calculate, over R, the gas constant, times temperature 1 minus temperature 2 over temperature 1 times temperature 2. It's a pretty big equation, but not super hard to use. As a reminder, the gas constant that we're using is 8.3145, and its units are joules per mole Kelvin. So it's going to be giving us the data for temperature 1 and rate constant 1 and temperature 2 and rate constant 2, and it honestly doesn't matter which one you choose to designate as 1 or 2. You're going to get the same answer either way. Just make sure that you match the temperature up with the corresponding rate constant, K. So I'm going to call this one number 1, and I'm going to call this one number 2 because that seems pretty logical to me. And then I'm just going to plug these numbers in. The natural log of my K1, which is 2.5 times 10 to the 11, divided by my K2, which is 6.3 times 10 to the 11. And that's going to be equal to my activation energy, which is what I'm trying to figure out, R, which is our constant, 8.3145 joules per mole Kelvin. And now it's time for the temperatures. And you got to be careful with the temperatures. They're giving us the temperature in Celsius, but it needs to be in Kelvin in order to work with R, which I left that unit out right there. So I'm going to convert both of these really quick to Kelvin. 438 plus 273 is 711 Kelvin. 518 plus 273 is 791 Kelvin. My T1 is 711 minus my T2, which is 791. I'm leaving the units off of this because this equation is cumbersome enough already. 711 times 791. And let's work out what we've got so far. So I'm gonna solve this part of the problem. 2.5 times 10 to the 11 divided by 6.3 times 10 to the 11, and then take the natural log of that, and I'm gonna get negative 0.92426. I'm gonna leave a lot of sig figs for now, and that's gonna give me E sub A over 8.3145 multiplied by, I'm going to work this math out right here, 711 minus 791 divided by 711 times 791, and that gives me negative 1.4225 times 10 to the negative 4. I think that what I'm going to do next is just get rid of the negative signs because I've got negative on both sides, so I can just cancel those out. And then I think that my next step, I mean, all that we're doing here now is algebra, so I think my next step is going to be to divide both sides by this 1.4225 times 10 to the minus 4. So 0.92426 divided by 1.4225 times 10 to the minus 4. I'm going to put this work up here, 6497.6, and that's equal to E sub A over R, 8.3145. And now I can solve for a 8.314 E sub A. So I'm going to multiply both sides by 8.3145, and that's going to give me 54024. That's my E sub A. Now, just in terms of units, because I got pretty lazy here and just dropped my units off, my units, it's going to want my units in kilojoules per mole. R has units of joules per mole. So right now in this form, this is in units of joules per mole because we haven't done any sort of joule to kilojoule conversion. So because we were using R with the joule format, when we get all of our math done, we're going to end up here with units of joules, not kilojoules. So all we have to do is just divide this by 1,000 to get it into units of kilojoules. And it only wants 2 sig figs, so that's going to be 54 kilojoules per mole.